Hi everyone, welcome back to the statistics course again. From the previous clip, we had introduced how to calculate the z-value, then for as the test statistic and use it to check the z-value table to get the probability. Okay, and such method we call it the p-value approach, and then we use that approach to test whether the hypothesis test can help us to reject or accept the new hypothesis. But now we will introduce another approach for you to do the hypothesis test. This test method is called the critical value approach. The critical value approach requires us first to determine the value for the test statistic. And the value for the test statistic, we will call it the critical value. So here you will find no matter you choose the p-value approach or the critical value approach, you need to calculate the value of the test statistic from your sample data. But for the p-value approach, that is, you use the test statistic to check its probability, then to compare its probability with the significance level alpha you get from your population, then to think about whether the new hypothesis should be rejected or accepted. But for the critical value, you need to do is to get the value of the test statistic. Okay, and then we call such value is a critical value. So for a lower tail test, the critical value will serve as a benchmark for us to determine whether the value of the test statistic is small enough to reject the new hypothesis. So the value of the test statistic that will corresponding to an area of the alpha in the lower test of the sampling distribution of the test statistic. And the critical value is largest value of the test statistic that will result in the rejection of the new hypothesis. So the critical value here we will find just like in the example you will find in your textbook that the hilltop coffee can the director say its tolerance for the type 1 error significance level is 0.01. So here you need to use such probability to find its test statistic value, okay? And also to use the sample to calculate out another test statistic value. So here you will find using the standard normal probability table, alpha 0.01, its z-value is negative 2.33. Okay, it's the value of the test statistic from the population and that you set from the second step. Okay, then you will think about if the sample will result in the value of the test statistic that is less than or equal to negative 2.33. Okay, so the corresponding p-value will be less than or equal to 0.01. So if in such cases is yes, then we will say we can reject the new hypothesis. So in the hilltop example, the X bar is the sample mean is 1.325 and the test statistic value Z. Okay, you calculate out from our previous clip is negative 2.63. So you will find it's smaller than the alpha 0.01. You calculate out its test statistic that its z-value is negative 2.33. So you can say you can reject the null hypothesis. So the rejection rule for a lower tail test, you use the critical value, that is, you can reject the null hypothesis if the z-value from the sample data is less or equal to the z-value you get from the population data, and is based on the alpha, the significance level you choose. Okay, so here you can look at this figure. That is, today you calculate out the z-value for your population is alpha 0.01, because based on the example statement, the director from the Hilltop Coffee can, it claimed that they can tolerance the type 1 error happen probability is 0.01. So you can check your z-value table for the probability 0.01 to get the z-value is negative 2.33. Okay, and then you can also to calculate the z-value you get from your sample. That is, you calculate out is negative 2.363. Okay, 2.63. It may be here, and you will find it will also include it in under the area of 0.01. Okay, so we can say we reject the null hypothesis. So here I would like to do a summary for the one-tail test. That is the p-value approach for you to test the hypothesis test, or you choose the critical value approach to do your hypothesis test. Their result will also the same. Okay, will be the same, because they will hope you to calculate the test statistic, and the test statistic in the condition that you know the population mean is z-value, and then you know the z-value and calculate out the probability. We call it the p-value approach. Okay, but if you just check the z-value and the significance level from the population, and then get such significance level to find its z-value and compare it with the z-value from the sample data, we call it the critical value approach. So no matter the lower or upper tail cases, we have to calculate the test statistic value z. So here you will find, because in our example, we use the lower tail test. And if you use the p-value approach, when the p-value is less or equal to alpha, okay, alpha is the probability you decide from your population, and the p-value is the probability you calculate from your sample data, from the z-value, and check the z-value table to get it. You will need to reject the null hypothesis. But if you use the critical value, you need to reject the null hypothesis if the z-value you get from the sample data and the z-value you calculate out or check the z-value table from the population data, you define the significance level of the alpha. Okay, if it's less or equal, then you need to reject the null hypothesis. And for the upper tail test, it will be the contrast condition, that is the p-value that is larger or equal to the alpha. You will reject the null hypothesis. And if the z-value that is larger or equal to the z-value from the significance level alpha, okay, you will reject the null hypothesis. So you can also watch in just like such figures. You will find if it's in the lower tail test, you will find you use the p-value approach. For example, today you set the significance level is 0.01, okay, and you calculate out your sample data result. Its p-value is 0.0721. It's under such area included is, so you can reject the null hypothesis. And if you use the critical value, you will find the under such condition, if you calculate out z-value for the you calculate the z-value from the significance level, okay, you will define under such probability or such value, you need to reject the null hypothesis. But if the sample data you get that is higher than such value or the probability you get from the population, then you cannot reject the null hypothesis. And the upper tail test will be on the contrast condition for them. Okay, you will find if it's larger or less, then you need to accept or reject the null hypothesis. So here you will find if it's an upper tail test for a critical value approach. Today, if we find the z-value is here from our significance level, that its probability is 0.05 and its z-value is 1.645. If it's larger from your sample data, you calculate out the z-value is larger than this, then you need to reject the null hypothesis. But if it's less than such value, you do not reject the null hypothesis. And this is we introduce about how to calculate or how to do the hypothesis test when we know the sample and the population mean, okay, in the one tail test. Thank you.